Awesome. All right, so we got section 2.5, transformations of functions with me, Mr. Hain. All right. Okay, we're going to talk about shifting and transforming functions, and the first shift I want to talk about, or the first transformation I want to talk about, is vertical shifting. So if we look at the original function here, the f of x, it's purple. We see that the only change to the g of x, which is in, I guess, dark green or black, is that it is moved. How? How did that move? The only thing, it might have looked like it moved to the left, but really we want to take a look at this point here, and it is indeed moved down. So if it's moved down, we recall that the formula for our line is f of x is equal to mx plus b, and that right there is where it crosses the y-axis, or the y-intercept. So here we see the f of x is on the positive side of the y-axis, and here the g of x is actually crossing the y-axis on the negative side. So because of that, I can say that it's moved down 5 units. So down 5, I'm actually subtracting from the end of the function. If I subtract from the end of the function, the c is just a number. In this case, it would be minus 5. It goes down 5. If I add to the function, at the very end of the function, it goes up. All right, so the next shift I want to talk about is horizontal shifting. So if we take a look at this f of x, it's a U shape here on the positive side of the x-axis, and it is actually slid over to the left to the g of x, and that is here on the x-axis to the left. All right, so it is definitely moved to the left. And if I tell you that the f of x is given by this function, x minus 3 squared, then I think the natural tendency would be, should we add or subtract to move left? Well, everyone thinks that the negative side is here to the left of the origin, so everyone wants to subtract. If you do subtract, though, you're going to find that is not the case. In fact, if I add just to x, as you see, if I did, say, x plus 1, so I added 4 squared, it would not move the function to the left. In fact, it would, if I added to it, would definitely move to the left, I'm sorry. But if I subtracted, which you would think it would move left, you would actually just move right. So I would highly suggest that you experiment with this right now. Go to Google and then just type in this original function, f of x is equal to the quantity x minus 3 squared, and then just say, and f of x is equal to quantity x, say, plus 1 squared. And you'll see it'll graph it on the same graph, and you'll see that when you add, or when you subtract, rather, it definitely moves right. And when you add, it definitely moves left. All right, so this is counter to what we usually think. So how can we analyze these functions now? So if I look at checkpoint 1, it says to rewrite the function f of x as the function g of x, where g of x is f of x shifted 3 units down. So if I'm shifting 3 units down, I definitely have to subtract from the end of the function, and so I'm going to suggest subtract 3. And you see I have this minus 3, and that's just placed at the back of that function, f of x. So I call it g of x because that's what the problem asked me to do, to rewrite it as a g of x, and I'm just going to shift it downward by subtracting 3. Why 3? Because it said 3 down. In the same way, I can name the transformations that happen here from f to g, from f of x to g of x. So I see here it's just f of x minus 1, and that minus 1 is happening just to the x because it's still underneath the square root sign in green here, underneath that square root symbol. So I definitely know that f of x minus 1 is right 1 unit. Remember, that's opposite of what we usually think. And if I look at the minus 2 at the end, notice it is not under the square root sign, so it's just at the very end of that function. I know now that it has moved down 2 units. That's a vertical shift. So we're going to talk about other transformations that happen, and the first is a reflection over the x-axis. When I reflect over the x-axis, I see that this g of x, I just have a negative in front of the entire function. Not the x, but the entire function. This was key. And a negative at the very beginning of the function changes the y values. So here in the f of x, you see these y values are all positive. But on the x-axis here, we see that the y values are negative. So it has flipped the graph over the x-axis, which is reflection over the x-axis. So that's just a negative in front of the entire function. So let's name those transformations. Let's take a look at g. All right. So the first thing that I see for part A here, my original function is just f of x squared. So there's a lot of changes. So I'm going to look at this and compare it with g. The first comparison, I see that it reflects over the x-axis because I have a negative sign here. I have a negative in front of, there's no negative here, so it has to reflect over the x-axis. The next thing is I see a +3 and it's happening just to the x. And we know, remember that the horizontal shifts are opposite of what we think. So this is actually just shifting it left 3. And finally, I see that I have a f of x -5. Now that -5 means that I have moved, and since it is at the very end of the function, means that I have moved down 5 units. So let's take a look at b. If I look at b, I have h of x. So again, I'm comparing h of x to the original x squared function. And I see I have a negative directly in front of just that x. That's reflecting across the y-axis. It's not the x-axis, but the y. And that happens when I just put the negative sign directly in front of the x and not in front of the entire function as I have for g. For f of x -4, I see I have a -4 here to just the x. This happens opposite. So you see here when I add, I move left in part A, but in part B, when I subtract, I have moved right 4 units. And this f of x +3 at the end means that I have moved up 3 units. All right, so let's take a moment. Let's see if we can actually catch up with C. It's m of x. Again, I'm going to compare it to the f. There's this change here, this negative, this -5, and this +5/3. If you pause the video, you can restart it now, and here we go with what each of those mean. It's reflected over the x-axis because I have the negative right here in front of the function. It is moved to the right because I have -5 to just the x. And this +5/3 means it has moved up 5/3. Awesome. So let's get into some deeper transformations. So we're talking about vertical stretching or shrinking. So this original function, f of x, is in green, and that's x squared. So that's the green graph that I've kind of sketched out here. And the only change that you're going to see is that the coefficient in front of the function changes. So if I look at g of x, you see that the g of x has changed here with the 3. And that's in red. And you'll notice here that it has actually gotten stretched. So the y values gained value, so they narrow the graph by stretching it upward vertically. Here we see h of x is 1/5, and that's a fraction, and so all of the y values have been divided by 5, which stretches, or shrinks the y values, making the graph appear much wider. And that's the h of x again. So here, when the constant in front of the function here, so here it is a 3 in g, and that is placed in front of the x squared, the graph is stretched upwards because the y values become larger. And here, when, and this is a fancy way of saying, is an interval for fractions between 0 and 1. So we see 1/5 is a value between 0 and 1. And what that does is the graph is shrunk because the y values are shrunk. And it appears wider and flatter. So that means it brings us to horizontal stretching and shrinking. So my original function, again in red, is this red line here, which is f of x -1 to the 3rd power. And you can always just plug these directly into the Google search bar, and then it'll pop out with a graph for you. And here we see the g of x is 2x -1 to the 3rd power, and the h of x is 1/2 x -1 to the 3rd power. Now notice the one things that are changing is the coefficient of x, so it's just the number directly in front of x. And when I saw here for the g of x in the dark blue, it actually made the graph shrink. It was narrower, so it shrinks the graph. But when I see that the value of the constant coefficient of x is a fraction, as in h of x here, it actually stretches the graph wider. Cool. So we're going to name those transformations. So all of these next slides, and I'm going to start with D, actually deal directly with our original function f of x, which is f of x +2 squared. So I've got a bunch of stuff happening here. All right, the negative in front reflects it over the x-axis. The 2 in front is a vertical stretch by a factor of 2. Again, it increases the values of y, so it makes the graph appear taller and thinner. And just the -4 at the end moves the graph down 4 units. Cool. So then here, if I have h of x, and again, this is always dealing with the original function, we're going to look at all of the different transformations. I'm going to label these differently. You see I have a whole bunch of arrows pointing in different places. The first one here is a negative in front of the x. That reflects over the y-axis. And then I have the 1/4, which is a coefficient, and that horizontally stretches and makes wider the graph by a factor of 4. And you see here I have a -1 directly after the x. It used to be a +2, so 2 to 1 is -3, so I subtracted 3, so it moves right 3 units. And finally, at the end of the graph, I have a +1, and that moves the whole graph up 1 unit. This is another way of labeling all the different transformations that are occurring. There are 4 transformations that are occurring to this graph, h of x, given our f of x here. So let's take a look at example f, or j of x. So there are definitely things that are happening here. You see the 3 is changed. It's no longer a +2, it's a +4, and I have a -3 at the end. So if you want to double check, you can pause the video and see if you can name these 3 transformations. So if you've unpaused, the 3 in front of the function definitely vertically stretches the y values by a factor of 3, so it makes the graph taller and slimmer. I've definitely added 2 to the x, because this is a +2 and now it's a +4, so it's definitely increased by 2, and that moves it left 2 units. Again, that's the one. Horizontal shifting is the one that's opposite of what we tend to think. I can only encourage you to put these 2 separate graphs into Google just as they are written, and it will show you visually exactly what I'm talking about. And f of x -3, this -3 of course just shifts the graph down 3 units. And that is the end of our presentation. I don't know if I had a slide for reflecting over the y-axis. It's not a big deal. You definitely want to rewatch this video, and I can only encourage you as much as possible to enter in the different functions that you've seen in the video so that you can see how they change visually in Google.